Today, we're putting on our detective hats because we're about to solve a classic chemical mystery. How do you figure out what an unknown substance?
All right, so picture this. Someone hands you a vial, and inside is just a plain white powder. It's an unknown ionic compound. So the big question is, how on earth do you identify it?
And in our chemical mystery, the biggest clues are the ions that make up this mystery compound.
Okay, so what exactly is an ion? Well, it's basically an atom or a molecule that's got an electrical charge because it's either lost or gained electrons. And here's the key bit. Every single ionic compound, like our mystery powder, is made of two different types of these charged particles.
You've got your positive ions, which we call cations. These are usually metals. And then you've got your negative ions, the anions, which are typically nonmetals. Our job is to figure out which tests will unmask each one of them so we can finally put a name to our mystery substance.
Right then, let's open up our forensic toolkit. We're going to hunt for that positive ion, the cation. And first up is one of the coolest tests, I think, the flame test. It's so simple, but it's incredibly powerful. All you do is dip a wire loop into your sample, pop it in a Bunsen flame, and boom! The color the flame turns can be a dead giveaway for the metal ion you're looking for.
And would you look at that? These are our first major clues. Each metal ion has its own signature color. You get this amazing crimson for lithium, a really bright yellow for sodium, and this gorgeous lilac for potassium. It's kind of like a personal fireworks show for each element.
But what if a flame test doesn't work? Or maybe the cation isn't one of those colorful ones? No worries, we've got another tool up our sleeve. This time, we dissolve our sample in water and add a few drops of sodium hydroxide solution. What we're looking for is to see if a solid, what we call a precipitate, forms.
And again, this test gives us another set of chemical fingerprints. Check it out. Different metal ions make these uniquely colored solids that won't dissolve. If you see a blue solid, you're looking at copper 2. A kind of sludgy green? That's iron 2. And a rusty brown precipitate is the telltale sign of iron 3.
Let's go hunt for the anion, the negative part of our compound.
First on our list is the test for carbonate ions. This is a classic. You add some dilute acid, and if you see fizzing, well, that's your first clue. But to be sure, you have to collect that gas and bubble it through lime water. If the lime water goes cloudy or milky, you've got yourself a carbonate. That's because the gas is carbon dioxide.
All right, next up, sulfates. Now for this one, you've got to be careful. It's a two-step process, and the order is absolutely critical. First, you add some dilute hydrochloric acid. Why? Well, this is to get rid of any sneaky carbonate ions that might be hanging around, because they could give you a false result. Only then do you add the main event, the barium chloride solution.
And what are we looking for? The money shot here is a white solid, a precipitate, forming right there in the solution. That white stuff is barium sulfate, and if you see it, that's a positive test for sulfate ions. You found them.
And last but not least, we're testing for the halides. That's chloride, bromide, and iodide. And you guessed it, we start by adding an acid again, this time nitric acid, just to clear the way. Then we add some silver nitrate solution. Now pay close attention here, because the precipitates that form have really subtle but super important color differences. You get a white one for chloride, a cream-colored one for bromide, and a pale yellow for iodide. You've got to apply the tests in the right order and, most importantly, write down everything you see.
Let's walk through an example to see how it all comes together. Say we do a flame test and get a green flame. Okay, observation 1, we've probably got the copper 2 ion. Then we do the halide test and get a white precipitate with silver nitrate. Observation 2, that points straight to the chloride ion. We just put those two pieces of evidence together and ta-da, we can say with confidence our unknown salt is copper chloride.
Now, cracking the case in the lab is awesome, but getting top marks in an exam, that's a whole different ballgame. And to do that, you need to know about some of the common traps people fall into.
Okay, listen up, because this is important. First off, contamination is your enemy. Even a tiny, tiny bit of sodium on your equipment will give you that super strong yellow flame, and it can totally hide other colors, like the lilac from potassium. And I can't stress this enough, always follow the right order for the tests. If you add the reagents in the wrong sequence, you're going to get the wrong answer. It's as simple as that.
And here are my top tips for the exam. You have to be specific. Don't just say, I do a test. You need to state what you do and what you'd expect to see for a positive result. And please, learn the precise colors. It's not just brown, it's rusty brown. It's not just yellow, it's pale yellow. Those details matter. And finally, just practice putting the two halves of the name together. Cation first, then anion, to name that final salt correctly.
So, before we wrap up, let's put your new detective skills to the test one last time. Here's the case. Your sample gives a crimson flame, and when you test its solution, you get a white precipitate with acidified barium chloride. So, what is it? Put the clues together, I'm sure you can solve it.